Good day, everybody. And once again, we are back together. And this time, I'll be bringing you the Maths Paper 2 exam from June 2024 from the Eastern Cape. So please, if you haven't subscribed, just please be part of the family. And by the way, just to bring you some good news, we will be hosting a camp, right, from the 23rd of September all the way to the 27th. And we are hoping to see you there at that camp. If you need further details, please contact the WhatsApp number that you will see on the description of this video. And for any other services, you are more than welcome to do the same. All right, so without any much talk, let's get right into it. All right, so we look at the first question that we're given there. They say to us in question 1, we've got the maximum daily temperatures in Bloemfontein for the first 11 days in January were recorded as indicated in the table below. Right, so there's the data that we've got there. So what I'm going to do is let me start by arranging the data, in ascending order. Let's see what's the minimum value. I've got 17 as the smallest value there. And so we've got 17. The next one would be, all right, I think it's 26. You'll help me out if I'm incorrect there. So that's 26. And I've got 27 after that. I've got another 27. Okay. And the next one is 30. And we've got 32. We've got 34. We've got 35, we've got 36, we've got 37, and finally we've got 40. Right, so there we have it. We've got all our data in ascending order. Right, now they say to us, calculate the mean of the maximum value daily temperatures of the first 11 days in January. Now, please remember, ladies and gents, Usually we're going to do this on our calculators, right? Now I've kind of taken the liberty to do that, but I'll take you through it. If you're using a Casio calculator, right? So remember, you're going to put your calculator in stat mode. So you're going to go to mode and then choose option 2, right? So you go to stat, you say mode option 2, or rather you say mode and then you press option 2. And because we are dealing with single variable data there, you are going to press option 1, right? Now, you're going to put in all of that data. Now, in my calculator, so there we go. We go for mode, and then I go to stat, right? All right, let me try and clear that so that you can see how it works. All right, so you go to mode. Then you go to stat, right? And remember, what am I choosing? I'm choosing the single variable data. As I said to you, I've already kind of put in the data for ease, but of course, in your case, you're going to do that. And please remember, you press the number, and to enter the number, you press equals to, right? And you're going to put all of these numbers, 17, 26, 27, and so on, right? And then once you've done that, ladies and gents, please remember to press clear, right? So you are going to press clear, or the AC button, all clear, right? And then you press shift, okay? Then you press option number 1, or rather press number 1, which is stat, right? And so you press shift, you say stat, right? You'll see that the one that you are looking for, the option that you are looking for is option 4, right? That's for single, you are calculating the variance there. So you press option 4. Now we are looking in this case for, so I'm going to go there, right? But in your case, you're going to press option 4. And then if you're looking for the mean, you're going to press option 2. Okay, right, and say equal to. Right, you'll see that you will get, I get a mean value of 31. Okay, Right, so we know that our mean value there is equal to 31. Right, and then they say to you, calculate the standard deviation. So you're going to do this exact same thing, right? Go back, say shift, you're going to stat. Now, you again, option 4. Now, for the variance in this case, or the standard deviation rather, you're going to press option 3, right? And say equal to. And in this case, I get mine. Okay, my calculator gives me everything all at once. So my variance, rather my standard deviation would be 6.19. Right, so that would be my standard deviation there. Okay, is 6.19. Right, now they say to us, how many days where the temperature is more than one standard deviation of the mean? Right, so we want to know which days will actually be, okay, x bar plus one standard deviation, right? So that's 1 times the standard deviation. So how many days were above 31 plus 6.19? So as that's going to be 37.19. Right, how many days were above 37.19? And I can see it's only 1 day, which is actually where the temperature was 40 degrees. So our answer there is that this is only going to happen in 1 day. Right, and they say to us, determine the interquartile range of the data. Now, first of all, ladies and gents, now that we've found, we've arranged our data in this way, we know that we are going to have, firstly, the mean, the median. So how many data sets do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Now, if I've got 11, then it means that the middlemost value, right? So meaning that my median will be the value that divides the data set into 2 equal parts. And I can see there that that will be 32, that value over there, right? Note how many data sets you have there. I've got 5 on the left-hand side, and I've got another 5 on the right-hand side, okay? Now, again, now I'm going to look for my interquartile range, which means I'm going to now look for Q1, right? So which one is Q1? Right, so my upper quartile, my upper values, right? It means that the values that are before the median, in this case, which one is the middlemost there? That would be 27, right? And which one is, so this would be Q1, okay? And in this case, Q3, the value that's in the middle there, right? So this would be Q3. Right, so ladies and gents, I can see that in order for me to get the interquartile range, IQR, I will say Q3 minus Q1, right? So that's going to be 36 minus 27. And you can see if I subtract those two values together, right, I do get 9, okay? Right, so in this case, that's my interquartile range. All right, so now let's go to the next question. They say draw a box and whisker plot diagram rather in the grid provided. So I don't have that grid, but I can do so. Right, so in this case, let's draw a number line. Right. Please, I'm not going to try and draw it to scale. So my minimum value is 17, right? In fact, let's do this. Yeah, so that it will be easy for us to. Okay, so that's going to be 17. Right, that's 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, so it doesn't look like my values are going to be. So I'm going to start from 17, let's say 19, 21, 23, 25, 27, 29. Okay, that's 31. Okay, 33, 35, 37, 39, and I'll have 41 over there. Right, now in this case, that means my highest value is 40. So 40 would be here. Okay. Right, so there's my 40 over there. And my minimum value, this is 17. Right, so we said Q1, that's 27. So there's our Q1 value over there. And we know Q2 is 36. So that should be here. Right, so already I can now try to draw my diagram. All right, and in this case, I know that all I'm simply going to do is just connect those together. Right, and there's my box and whisker plot. Okay. Right, so that's the first value. That's the maximum value, which is at 40. Right, that's my box and whisker plot, and I know that at 32, this is where I have my median. Okay, so my median would actually fall right here. That is my box and whisker plot, and remember we said this is Q1, this is Q3, right? And that's what it looks like. Ladies and gents, there's no reason why you shouldn't be able to get full marks here. It is essentially just free 12 marks. Right, as we are going to move to the next question. Right, I hope that you understood this. Right, so let's look at question 2 of this this June question paper. Right, so they say in a certain school, the analysis of mathematics metric results in percentages were represented in the cumulative frequency graph, the ogive, right, given below. Right, so they say to us, use the above graph to answer the following questions. Right, so firstly, they say complete the question, the frequency table provided in the answer book. All right, so let's try to complete what we have there. Now, ladies and gents, remember, whenever we talk about the cumulative frequency, right, whatever value we have here, okay, let's take that. Okay, so whatever value that we've got here, we add it to the value, right? Or rather, let me put it this way. The frequency in this case, of course, the cumulative frequency, the first one would be 4, right? Now, for me to get 18, so which means 4 plus whatever value that I add here, okay, plus this value will give me 18. Okay, so what plus 4 should give me 18, right? Or I can say 18 minus 4, that will give me 14. Right, and again, right, to get the next value, right? So 18 plus whatever value there will give me 36. So what is it that I can add to 18 to give me 36? That should be another 18. Okay, so my eraser is giving me a bit of a challenge. Right, let's go for it. So we said the value is 14 there. Right, so this is 18 plus another 18 will give me 36. Right, and again 36 plus what value should give me 50. That should be another 14. Right. Okay, I think my eraser is just too big, and that's why it's giving us some issues. Right, so 36 plus 14, right? That would give me the 50 there. And then again, so 50 plus what should give me 54? That should be another 4. All right, so there we go. There we've got our frequency values. So this value here should be 4. And by the way, when I add all of those values, they should actually give me 54, which is the total number of participants, right? All right, so please remember that. So they've given us the cumulative frequency. So usually they give us the frequency and they want us to determine the cumulative frequency, right? So this value here, these are always the same, right? But to get the next value, I will take, remember, once I've got this value, I'll add to that value, right? The frequency value, the next frequency value to get the next value. And you'll see that once you go to your graph, it will actually agree with what we've got there. The first value on your graph will be 4, and which means that the second value should be 14 and so on. Right, now they say to us, write down the modal class. Right, so the modal class, this is where we've got the greatest frequency, right? So the most number of people, and you can see that our modal class will be between 40 and 60. Right, so our modal class will be x greater than 40 and less than 60. Right, greater or equal to 40 and less than 60. Right, now they say to us, estimate the median percentage for mathematics of the school. Right, so what is the median? Remember, the median is the 50th percentile, right? So in this case, 50% of what? Of the number of people. And how many people do we have in total? That's 54, right? So we want to find out, in this case, I'm going to take my ruler to try and determine that. So what's 50% of, and remember 50% is 0.5, so that's 50 over 100. So 0.5 of 54, that should give us 27, right? So I want to find out, okay, let's look at, let's take our ruler there, and we're going to look at 27. So this looks like they increase by 1. Okay, so that's 20 over there. That's 1, 2, 3, 4, 5, 6, 7. All right, so I'm going to take, right, let's take the smaller pencil. So that's 27 over there. Okay, and what is the value that relates to 27? Actually, I just took it a little bit below, so just for us to be on the accurate side. And that's 1, 2, 3, 4, 5, 6, 7. Okay, so I just want us to be as accurate as possible. Yeah, we've got it now. And what is the value that corresponds to 27, the percentage? Right, so I can see those increase with in twos in that case. So that means that that's 40. Yeah, it looks like that's 50, right? So that's 42, 4, 6, 8, 10. So that should be 50. All right, so that means that our estimated median percentage of the for mathematics at the school is actually exactly 50%. Okay, right. So now they say to us, if the requirement for a learner to be admitted in a certain institution is 70% and more in mathematics, right, determine how many matriculants will qualify for admission. Right, so we're going to look at 70% and check how many students are above that threshold of 70%. So that's 62, 4, 6, 8, 10. So that's 70 over there, right? So I'm going to draw a line there at 70. Okay, so, all right. So, actually, our line is exactly here. Okay. Now, let's check. How many learners are at that 70th mark, or what's the cumulative frequency in that case? So that means that if I look at that, okay, I just missed it just a little bit. I think the correct value is the one just slightly above. So that's 40, that's 2, 4, 6, and 8, right? So the value of the cumulative frequency there is 48. Okay. Now, ladies and gents, meaning anyone from this value here going all the way till the maximum value would be above that 70%, right? Threshold that they have given us. So I'm going to say 54 rather, minus, that's minus the 48 learners, right? So that would give us what? 14 learners, right? So that means that so we are saying 54 minus 14, minus 48 rather. Actually, that's 6 learners. How did I even count there? Right, so that's 54 minus 48, and that would give us 6 learners. All right, there we go. Ladies and gents, that means that only 6 learners would be able to qualify over that 70% mark. All right, so as we are going to move on to the next section, right, just one thing that I want you guys to be aware of in this section. Please remember, you have to be able to get, what we call in this case the average mean, right, of this data. And how you do that, I know this is not what was asked, but I just thought, let me just include it there. What you always do is you're going to take your, right, so you're going to go to your median values, right, of each of the class percentage that you are given, right? So from 0 to 20, your median is 10. So you're going to say 10 multiplied by the cumulative frequency, the frequency value. So that's 10 times 4. And here you've got the median value would be 30. You'd have 30 multiplied by 14. Okay, so you had 4 there. So 30 multiplied by 14. You'll have 50 multiplied by 18, you'll have 70 multiplied by another 14, and finally you'll have 90 multiplied by 4, right? So you add all of those values up, right? So you'll find the sum here, right? You add all of those values up and you divide that by the number of participants there, and that would give you the value that you are looking for. All right, ladies and gents, I will leave it there. And by the way, you do have the formula to this right at the end. If you look at your data sheet, let me just show you that value there. Okay, okay, so sum of your F. Okay, right, there you have it over there, divided by n. Right, so ladies and gents, that's how you are going to be looking at question 2. Right, and let's go right into the next question. Right, so let's look at question number 3. Right, so they say to us in the diagram below, we've got A, which is -2 and P, B, -4 and 0, C, -1, -3, and D, 4 and -1, which are the vertices of a trapezium. Right, so remember that a trapezium has got one pair of parallel lines. Right, they say AD is parallel to BC, right, as it's given in the diagram. They say point G is the y-intercept of the line AD, right? I think that is very clear there. And they say F lies on the line AD. Right, so let's get right into it. They say determine the length of BC. Right, so we've got the 2 points there. So I'm going to say, well, we know our distance formula. So BC will be the square root of XB minus XC squared, YB minus YC squared. Right, so we're not going to waste time on this one. So we're simply going to say the X value at B is -4 minus the X value at C. So this is minus a -1, right? So remember, minus minus gives us a plus. So that will be +1 squared. Okay, plus. Now let's take the Y values. Y value at B is 0. So that's 0. And the Y value at C is -3. So that's minus a -3. So that's +3. All right, ladies and gents. So we'll get -3 squared plus another 3 squared. That will give us 9 plus 9, which is 18. Right, so we can say that this is equal to the square root of 18. Otherwise, you can say that, remember that square root 18, 18 is 2 times 9, and square root of 9 is 3, right? So this would be 3√2 units. All right, so that's the value of BC. Let's go for it. They say determine the gradient of BC. So we're looking for the gradient now. So MBC, we're going to say YB minus YC over XB minus XC. Okay, so YB, as we did say, that's going to be 0 minus YC is -3 divided by XB, that's -4 minus XC is -1. Right, ladies and gents, so that gives us +3 at the top, okay, and it gives us -3 at the bottom. So we can see that that is a negative gradient, so which means that the gradient of BC must be -1. All right, so we are good there. They say determine the equation of the line, okay? Determine the equation rather of the line AD in the form y is equal to mx plus c. Now please remember, guys, that when I look at the line AD is parallel to line BC. So I can say MBC should be equal to MAD, right? Right, so the reason there is that AD is parallel to BC. Right, so now what do I have? I've got that as -1, the gradient, but I do have a point that I can actually substitute. So already the equation is going to be y is equals to -1. Remember that the gradient was -1. So that's -1x plus c. Now to get the value of c, all I'm simply going to do is just substitute the x and the y value there. So when y is -1, okay, x is +4 plus c. Right, so -1 times 4 gives us -4. If I take the value to the other side, we've got +4 minus 1. So our c value is equal to a positive 3. So the equation is y is equal to minus x plus 3. All right, so that already tells us that this line cuts through, which means the point G is the line 0, where x is 0 and y is 3. Right, now let's go for the next value. They say calculate the value of P. Right, so where is P? So P is actually the y value where a is negative 2 of the same line. So now that we've got the equation of that line, okay, I'm going to say, right, 3.4, right, I know that y is equal to negative x plus 3, but I want the y value. The y value is P, right, when the x value is negative 2. So remember, there's already a negative there. So that is a negative 2 plus 3. So that gives us 5. So the value at P is actually equal to 5. All right, ladies and gents, let's get to the next point. They say if the coordinates of F are 5 over 2, so F is that point over there. Say it is 5 over 2 and 1 over 2. So they say show that CF is perpendicular to AD. Now, ladies and gents, we already know the gradient at AD is equal to negative 1, right? You remember we found that line there. So let's find the gradient at CF. And remember, if lines are perpendicular, the product of their gradients will be equal to negative 1, right? So 3.5, we're going to look for the gradient of CF. So YF minus YC divided by XF minus XC. So this is going to give us 1 over 2 minus a negative 3 divided by 5 over 2 minus a negative 1. Okay, so y2 minus y1, x2 minus x1. Right, so what do we get there? So we've got 1 over 2 plus 3. Okay, so that would be 7 over 2, isn't it? Okay, yeah, just to be on the safe side. Yeah, so we've got 6 over 2, which gives us 3. Okay, so we've got 7 over 2 divided by another, we've got 5 over 2 plus 1 again, which gives us 7 over 2. So 7 over 2 divided by 7 over 2 will definitely give us 1. Okay, so the gradient of CF is 1. So definitely, I know that the gradient of AD multiplied by the gradient of CF are equal to negative 1. Remember, negative 1 times 1 will give us negative 1. So therefore, that means that CF is perpendicular to AD. All right, so there we have it, ladies and gents. All right, so now the last part of it, or well, almost the last part, they say calculate the size of angle theta. Now, ladies and gents, let's look at where theta is located. So I'm going to take this triangle over here, and I'll show you why I'm taking that triangle, right? So I already have the gradient of the line AD, which means I would be able to determine, in this case, this angle over here, or if at worst, I'd be able to get that little angle over there, the angle of elevation of line AD, right? So I am going to say, let's look for Right, so you remember that tan of an angle, right? So I'm going to say tan of any angle. Let's call that angle beta. Okay, so tan of beta is equal to -1. So what should be the value of beta? That's arctan, the inverse tan of -1. And that should give us -45, right? So shift tan of -1. That gives us -45. But remember, what is that angle there? It's actually giving us the angle that is in here, because we are now taking it from the negative x-axis, and in that case we get that to be -1. So at the end of the day, ladies and gents, what we are going to do is, we know that the value of theta, you can add 180 to that, so plus 180, and that will give you 135. But now here's the most important thing. Ladies and gents, if you're looking at 135, in fact, let me just remove this there. So which means this angle here is 135, right? Now remember that this is the exterior angle of that triangle. So 135 is equal to the opposite interior angle, which is 90 plus theta, right? And so theta will actually be 45. Alternatively, what you could have done is, you already know that this angle here is 45 degrees, right? So that already tells you that if this is 90 and that's 45, then theta that is also going to be 45 degrees, right? So theta, therefore, angle theta is 135 minus 90, which is equal to 45 degrees, okay? And you can say that this is exterior angle of a triangle. Okay, right, remember that the exterior angle of a triangle, or rather let me also specify which triangle as I was referring to. So that would be triangle OFG, right? Triangle OFG. All right, and then finally, ladies and gents, they want us to calculate the area of a trapezium. Now, we've already proven that line CF is a line that is perpendicular to the one side of a trapezium. So that is perpendicular over there. So which means we can say that that's a vertical height. Now, please remember, the area of a trapezium will be half the sum of the two parallel sides, right, multiplied by the perpendicular height. So in this case, I would say, well, the area of trapezium ABCD will be half the sum of the two sides. Now, the two sides that you've got are side AD that are parallel and BC. So that would be AD plus BC, okay? And this is multiplied by the perpendicular height, which is CF, okay? Right, so that would be half the sum of the two parallel sides multiplied by the perpendicular height. Now, we are going to find, do we have the length of AD? Did we find that? No, we found the length of BC. So we don't have the length of AB. Okay, so we're going to find that. So AB would be equal to, so let's say that's going to be x2 xd minus xa. So that's going to be 4 minus a -2. That gives us +2 squared, plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you've got 4 minus a -2 plus, in this case, you the y values. You've got -1. We found the value of p. I remember, okay, it was 5. So that's -1 minus 5, right? So -1 minus a +5 squared. Right, so let's put that in our calculator without necessarily wasting any time. So this is 4 plus 2 squared plus, we've got -1 minus 5 also squared. All right, so I'm going to give that in third form. So that's 6 root 2 units. All right, and the perpendicular height, which is CF, we also don't know the value of CF. So I'm going to calculate the value of CF there. Right, so once again, for the value of CF, you've got the coordinates there. Remember, we're given the coordinates to be 5/2. Okay, so the coordinates of F are 5/2 and 1/2. So, going to say 5/2 minus a -1. We didn't calculate CF anywhere, right? Actually, we only found the gradient of it, yes. So we've got 5/2 minus a -1, so that's +2, +1 rather, squared, plus the y values, so that's 1/2 minus a -3, so that's +3 squared. Right, so we've got 7/2 plus another 7/2 again, squared. So we're going to say, right, so let's do that. So that's 5/2 plus 1 squared plus 1/2. You add that to 3 squared. Right, ladies and gents, we've got 7 root 2 over 2. So this is going to be 7 root 2 over 2 units. Right, now let's find out what the area of this trapezium is. So that would be half of AD. Okay, actually this was supposed to be AD, not AB. Right, so that's 6 root 2 units plus BC. We already had found the value of BC. That's 3 root 2 units multiplied by, we said that's 7/2 root 2. Okay, ladies and gents, you can actually just calculate that directly. That would give you 9/2 root 2, right, plus 7/2 root 2. If you want to, we can calculate it directly like that. So that's 6 root 2, okay, plus 3 root 2. So just be careful when you are adding there, not to put the numbers in or underneath the square root, right? So that's multiplied by 7/2 root 2. All right, and so ladies and gents, I find the area to be equal to 31.5. Please remember, like any other thing that's area, that's going to be unit squared. Okay, right, so that's going to be square units in that case. Right, ladies and gents, that's how the cookie crumbles for this question. I hope you are able to follow on. Right, let's go on to the next portion. See you guys just a bit. And now let's look at question 4. Right, they say in the diagram below, we've got a circle with center C, which is 3 and -1 and a radius of 10 units. which is drawn, right? So they say PQR and PT are tangents, all right? Please remember, we're going to need to apply theorems from Euclidean geometry here. And already I can see tangents from the same point. Right, so they say at Q and T respectively, and they say PT is parallel to the x-axis, right? So that means that is a horizontal line, and R, which is K and 21, C and P are vertices of triangle RCP, and they say QR is 20 units. Right, now ladies and gents, let's get right into it. They say write down the size of angle CQR. So let's see, CQR. Okay, so it's that angle there. Right, and in this case, what would that angle be equal to? We can already see that's a 90-degree triangle, right? That's a 90-degree angle, rather. Why is that? Because of the 10 radius theorem. So angle CQR is equal to 90 degrees. Let's give them a reason. That's 10 tangent perpendicular to the radius. All right, so let's get the length of RC, and they say leave the answer in third form. All right, let's look at RC. Right, we are given there that QC is 10 units, and we've got QR, which is 20. So we can use the Pythagoras theorem and say, well, RC squared is the square of the hypotenuse is equal to, in fact, maybe let me also state, in triangle QRC, right? So we said RC squared is equal to QC squared plus QR squared. Right, so in this case, we know that our QC value is 10 units. QR is given as 20 units. And we're looking for RC, so we might as well just take the square root. So RC, okay, let's take that value. So this is the square root of 10 squared plus 20 squared. And we get 10 root 5, so that's 10 square root of 5 units. Okay, so that's the value of RC. Okay, so I'm just going to put that there. I don't know if we're going to need it at some point, but I'll just put it there. Right, now they say to us, calculate the value of K if R lies in the first quadrant. All right, so we're looking for the value of what K is. Now remember, we already have the length of the line RC, and so in this case, we can use that to determine the length, right? To determine the length, the value of K. Right, so I'm going to say, but I know that RC is 10 root 5. So that means RC is equal to the square root of. Now note, this is going to be x1, so that's K minus 3 squared, plus, in this case, so that's K minus 3, that would be 21 minus a negative 1, right? Actually, I should have written down the individual, the formula first. So that's 21 minus a negative 1. Okay, that's squared. Ladies and gents, let's not even waste time with that. Let's put it, so 21 plus 1 will give us 22 squared. But we remember that RC is actually 10 root 5. So let's square both sides. Okay, so 10 root 5, this will give us 500, right? Okay, so remember the square cancels out the square root. So we've got k minus 3 squared plus. Now remember this becomes 22 squared. 22 squared. So I'm going to take the 22 squared to the other side. So this is going to be, firstly, let's verify that 10 root 5 squared is indeed. So I'm going to put this in brackets and square it. Right, definitely it is 500 minus 22 squared. I get 16, so I have k minus 3 squared is equal to 16. And so that means that k minus 3, take the square root on both sides. But remember, when I take the square root, I'm going to have plus or minus. So that will be plus or minus 4. So k minus 3 is equal to 4, or k minus 3 is equal to negative 4, right? So k is equal to, if I take this to the other side, it becomes 7, or k is equal to, right, negative 1. All right, and please, I want you to note in this case, they did say it is in the first quadrant, so it has to be a positive x value. So therefore, it means k is equal to 7 and not equal to negative 1. All right, so that one is not applicable. So we already have the value of k. Okay, that's going to be 7 over there. Right, now they say to us, determine the equation of the circle with center C passing through T and Q. Write your answer in that format. All right, now, ladies and gents, we know that we are going to have our A and B value is the center. So this will be x minus 3. Please remember that they change sign, right, when they are inside the bracket, plus. That's y plus 1, right, because our y value there is negative 1. So that also changes sign, squared. And we know the radius is given there in the form of CQ. We know our radius is 10. But remember, we say radius squared. So that will be equal to 10 squared, which is 100. So that is really how we get that equation. Right, now they say to us, determine the equation of PT. Right, let's look at which one is PT. So if we look at that, there is PT over there. Right, it is a horizontal line, which means if it's a horizontal line, its gradient is 0, right? And in this case, remember that it should be parallel to the x-axis, so it should be the line y is equal to something. Now, if I note there, ladies and gents, I can actually draw a line from C to T such that, remember, if this guy is a tangent, then it means it is perpendicular to that line. Now remember, what it means is that at T, our x value should be the same as the x value at C. So the x value is 3, as well as now the y value. Right, remember that our radius is 10 units, right? So I'm going to say, well, in this case, if I look at x value at C minus the x value at T, that should be equal to 10 units. All right, so in this case, our x value at C, rather not the x value, the y value I should say, apologies about that, the y value at C, the y value at, so y value at C minus the y value at T, that should give me 10 units, right? So that means if I look at this, my y value at C is negative 1 minus yt is equal to 10, right? So if I take that to the other side, negative yt would be equal to minus 11, right? And would be equal to 11 rather. And so that means that the y value at t is actually negative 11. Right, so please remember, guys, it is a perfectly vertical line, that is the line CT. And so in this case, it means that it would actually just, between C and T, that would be a vertical line. And so the only thing that differs is the other y values, right? So the equation of PT, I want you to note, so this line passes through negative 11. So that equation would simply be y is equal to negative 11. Okay, right, so remember that's how we get a horizontal line. It's characterized by y is equal to. Now let's continue. They say the equation of line PR is given by 3y minus 4x is equal to 35. So, okay, so they say calculate the coordinates of P. So let's do this first, ladies and gents. Let's rewrite that in the standard form. So this is going to be 3y is equal to 4x plus 35. And if I divide everything by 3, that means y is equal to 4 over 3x, and in this case, plus 35 over 3. Right, so that is my equation for, these are the coordinates of P, right? So, if I look at this, so that would be the line, that is the line PR, the equation of the line PR. Now they said to us we need to find the coordinates of P. Right, now I want you to note, if this is a horizontal line, I already know that the y value at P is negative 11, right? But I also know that P is also together with the line PR, right? So PR is that line there. It also passes through P. So we are looking for the x value at P when y is negative 11. So all I'm simply going to do, ladies and gents, going to say, let's look for the x value when y is equal to 11. So 4 over 3 x plus 35 over 3. Right, so let's try and work that out. So negative 11 minus 35 over 3. Okay, we get a value there. We get negative 68 over 3. Which is equal to 4 over 3x. Now our denominators are exactly the same, so we can drop them. So I'm left with negative 68 divided by 4, right? Or if you wanted to, you could have just simply said we multiply by 3 over 4, the inverse of x. So what I do on the left, I will also do on the right-hand side. Okay, so that cancels with that, that with that. That 3 cancels with that. So we've got 68 divided by 4. And that tells me that x will be equal to negative 17. Right, so the coordinates of P, negative 17 and negative 11. And I can already see that it is in the third quadrant. So definitely my x values should be negative. Right, so that's minus 17 and minus 11. Now, then the next question says, calculate the length of PQ with a reason. Right, now let's go and check. So PQ, I want us to quickly see that, right? So if I look at the line PQ, ladies and gents, what we've already noticed is that these are tangents from the same point. So the line PT and the line PQ should be equal, right? Why? Because these are tangents from the same point. So in this case, is it possible for me to find the line PT? Yes, it is, because I've got the x value at P, I've got the x value at T. And remember, the y values are equal. So in that case, because it is a horizontal line, I will simply take the difference between the x values. So I'm going to say, right, firstly, let's find PT, which is xp minus xt. This is negative 17 minus 3 right, but remember the length in that case is never negative, so therefore PT is equals to 20 units, right? So that means this is going to be 20 units, but we know that PT, PQ is equal to PT, which is 20 units. And the reason for that is that these are tangents from the same point. Okay, right, now they are asking us, is the area of triangle QRC equal to the area of triangle QCP? Right, so we know that this is 20 units. So they're asking, is this area QCP, is it equal to the area of triangle QRP? And I will say that is very true, because remember, their bases are equal, right? Both of them 20 units, and perpendicular height is common, which is QC. So in that case, it means our answer will definitely be yes. Okay? They have equal bases. That is PQ is equal to QR, and equal height, which is common. Okay, so our height is QC, which is common. All right, and so there we go, ladies and gents. Now they say consider, sorry that looks a little bit messy there. Okay, I'm just going to remove it so we're able to read. Right, they say consider the circle with equation x minus 3 and y plus 16, which is equal to 16, that is all squared, right? Which is equal to 16, and having a center at M. Okay, they say write down the coordinates of the center. Right, so which means the coordinates of the center, remember, this would be the x value of the center, this would be 3, and the y value of the center is negative 16. Right, so this would be M. Okay, now they say to us, write down the length of the radius of the circle with center M. Now note, our radius is going to be 16, right? Or rather, r squared is equal to 16. And so that means that r is equal to the square root of 16, which is 4. So radius would be 4 units. Right, now they want us to prove that the circle with center C and the circle with center M do not touch each other. Now remember, ladies and gents, what happens if two circles don't touch each other? Right? It means that if I were to take, so if these are the coordinates of M and these are the coordinates of C, right? If I take the sum, or rather the distance MC, right, it will be greater than the sum of their radii. So let's say R1 and R2 there, right? So if you take R1 plus R2, it will definitely be less than the length of MC. So let's find the distance MC first. So this is going to give us xm minus xc plus that squared plus ym minus yc. This is squared. This is going to give us, okay, so let's write that down nicely. Right, so the x value at M, we said this is 3 minus the x value at C. Remember we said that's also going to be 3, right? So that's 3 minus 3 squared plus y value at M, we said that's negative 16 minus the y value at C. Remember, our y value at C is negative 1. So that's going to be minus 16 minus a negative 1, which is plus 1 squared. And so what do we get for the value of MC? Right, we've got 15, negative 15 all squared, right? So actually we can just simply say this will give us 15 units, right? Now let's find the value, or rather the sum of their radii. So MC is equal to 15 units. So let's find R1, or rather radius 1 plus radius 2. So the radius of the first circle, which is the circle with center C, the radius is 10 units. So that's 10. And the radius of this circle, we found it to be 4 units. That's going to be right. Now, in this case, please remember, ladies and gents, so we said MC, the distance, in this case is greater than R1 plus R2. And so therefore, it means that the circles do not touch each other. All right, ladies and gents, that is how the cookie crumbles. That's 23 marks. I mean, that's a lot of marks for us to just, to just miss them. So let's make sure that we know this section quite well. And, people tend to underestimate it. We need to make sure that we maximize on the marks that we get in this section. All right, ladies and gents, let's move on to the next question. And now we get on to question number 5. They say if sine of 14 is equal to P, right? Without using a calculator, determine the values of the following in terms of P. Right, so the first thing that we're going to do here is that we need to first find an expression for the value of, or rather we need to find the triangle, right, for the sine of P. So we know that sine of 14 rather, so we know that's our 14 degrees there. So that means this is P over 1. Now remember, sine is opposite over hypotenuse. So that will be opposite, which is P over hypotenuse, which is 1. So to get the corresponding, the y value, so we're going to say, rather x squared, the x value rather, x squared is equal to y squared minus, r squared minus let me write it in standard form. X squared plus y squared equal to r squared. So that means that x squared is equal to r squared minus y squared. And that gives us 1 squared minus p squared. And in this case, all we're simply going to do is take the square root of that. So to get x, that's going to be plus minus the square root of 1 minus p squared. But remember, this is in the positive x, rather this is the positive x values. It's in the first quadrant. So that value is 1 minus p squared. Now, for some of you, you find it actually quite valuable to also find the other angle, that is the angle over there, right? And all you do to get that angle, you say 90 minus 14, and that would give us 76. Okay, right. So when they say to us, find the cosine of 76, all we are simply going to do is say, well, we know that cos is adjacent over hypotenuse, but we're looking at 76 degrees. The adjacent side is that side. The adjacent side is P rather. Okay, so let me just try and erase that. Okay, let's get rid of this guy. Right, the adjacent side is P over the hypotenuse, which is 1. Or what you could do here is say, well, cos of 76, how do I express it in terms of 14? This is the same as saying, right, this is cos of 90 minus 14. Okay, right, I haven't changed anything. 90 minus 14 is 76. So, but we know whenever we've got 90 minus, this will change into the co-ratio, which is sine of 14, and we know sine of 14 is p, right? And so that's the expression in terms of p. Now, then they give us cos of 44 degrees. Now, ladies and gents, you can try out any of the combinations, right? Sometimes you use our, what we call our special angles, or we can even use, in this case, the reduction formula, right? That is 90, 180, 270, and 360. But that definitely won't give you 44. The only way that we can get this in terms of 14 is if this becomes the cos of 30 plus 14, because 30 is a special angle, right? So then what we're going to do is we're going to use, okay, please allow me to use the space here. So cos of 30 plus 14, we're going to use what we call the compound angle formula of cos, that's cos 30 cos 14 minus sine 30 sine of 14. Now cos 30, this is root 3 over 2 times cos 14. Now you remember we said cos of 14, or rather cosine of 14, this would be adjacent over hypotenuse. This would be the square root of 1 minus p squared over 1. That's minus sine of p. This is, sine of 30 rather. This is 1 over 2. Sine 14, we've already said this is p over 1. Okay, so what do we get? We've got root 3 into 1 minus p squared. Okay, I'm using the third rule, that the square root of that times the square root of that. I'm putting all of them under the same square root, over 2 minus p over 2. So we can add all of this up. This will give us minus p plus the square root of 3 into 1 minus p squared This is divided by, all of it divided by 2. Right, ladies and gents, that's how we would get that number over there. Right, so let's go to the very last one. Okay, so for the sake of space, I'm going to remove our previous one. You can play the video back if you want to see it. Right, so they give us 2 sine of 218 cos 38. Now, firstly, I can see that, if I look at that, it doesn't necessarily give me something that I would be able to use, right? It doesn't, there's nothing in terms of 14 there. However, this does look like the double angle formula for sine, isn't it? 2 sine x cos x, right? So all I need to do is reduce this angle here, 218. So let's do that. So 2 sine, okay, 218 is 180 plus 38 cos of 38. Now, if I say sine of 180 plus 38, that's in the third quadrant, and I know sine is negative there. So this becomes minus sine of 38 cos of 38, right? That does look very impressive. So this is negative. Now I'm taking the negative out there. That's negative 2 sine of 38 cos 38. Right, now guys, I want you to notice in this case, we've got the double angle formula for sine. And in this case, it simply means if I've got 2 sine theta cos theta, that simply changes to sine of 2 theta. So it means I will double the angle that I see there. So this is negative. We shouldn't forget that negative there. This will be minus the sine of 2 times 38. Okay, and I see that 2 times 38 is 76. Right, so if I say minus the sine of 76, so sine is opposite over hypotenuse. Okay, so that would be minus the square root of 1 minus p squared over 1. Right, ladies and gents, that is really how the cookie crumbles for those guys there. Right, I hope that you got it, ladies and gents. That is how we would answer those questions. Right, now let's go to the next portion. I'm going to need some space, as much space as I possibly can get. Right, so they say to us, given 1 plus, this is sine 90 plus theta, cos of theta minus 360, sine of theta minus 30, and cos, times cos, and sine of theta, and cos of theta minus 30. Right, they say simplify to a single trigonometric ratio of theta without the use of a calculator. Now, ladies and gents, what I'm going to do is, right, we note we still have this 1 over here, so I'm going to leave the 1 there. But sine of 90 plus theta, now let's have our cast diagram there. So we know we'll have cast sine of 90 plus theta, that's in the second quadrant. Sine is positive, but because we've got 90 there, that becomes cos of theta, okay, multiplied by, right, so we've got cos of theta minus 360. So I always say, please just add 360 when you've got a negative reference there. So I know that the positive 360 will cancel the negative 360. I'm left with cos of theta. Now remember that anytime you add or subtract 360, we are left with exactly what was there originally, right? Because adding or subtracting 360 does not change anything. Right, now if you look at this, when I look at this, it looks like the compound angle formula for sine. So if I've got the sine of A plus B, okay? Or rather, let me say a minus b, because there's a negative there. Remember, what does it give me? It gives me sine of a cos b minus cos a sine b. Right, now look at this. This looks like your a, cos, that's your b, and that looks like your, so if this is a, so you've got cos a here, you've got sine of b. Right, so I'm going to just simply try to convert it back to this. So my a is theta minus 30, right? And my b is theta. So I'm going to say this is equal to the sine of, right? A is theta minus 30, right? And this is minus b is theta. So ladies and gents, if you notice that will be theta minus theta. That will give me, those cancel out. So I'm left with, at the bottom, I've got the sine of negative 30. Okay? Right, so let's try and complete that. So this will give me 1 plus. Okay? So this will give me 1 plus cos squared of theta divided by, now remember, sine of 30 is actually, sine of negative 30 rather. You can say 360 minus 30, that would give us as minus the sine of 30, right? So this would be minus the sine of 30, that's in the fourth quadrant. Okay, and sine of 30 is 1 over 2. So that's 1 minus, now remember, positive divide by negative, that will give us a negative, right? So that's minus, right, cos squared of theta divided by 1 over 2. Now remember, ladies and gents, if I multiply the bottom by 2 and that by 2 so that I get rid of that 1 over 2, I am left with 1 minus 2 cos squared of theta. Now remember, the cos of a double angle gives me 2 cos squared of theta minus 1. And it looks like they have changed it around there. Okay? So that means if I take out the negative, I will now be left with minus 2 cos squared of theta minus 1. If you multiply that negative in, it gives you back exactly what we had initially. And so that means this is going to be minus the cosine, okay, of 2 theta. Right, so we've reduced it to a single trigonometric ratio. Right, so all of this is equal to negative cos of 2 theta. Right, so we've answered the first question. They say to us, write down the maximum value of this entire thing. So remember, we've already proven that it's equal to negative the cosine of 2 theta. And if you notice there, the maximum value, the graph of cosine has got a maximum value at 1. So in this case, it means that the maximum value is simply equal to 1. All right, I hope that you got that, ladies and gents. Really quite an interesting question. Right, let's go to the next portion. Now they give us there, we need to prove those identities, right? They say we've got sine of 3x over x equal to 3 minus 4 sine squared of x. Now, please, I want you to note, ladies and gents, whenever we are proving identities, now I'm going to try and answer this over here. I hope that I do have enough space. So this will be sine of 3x over sine x, right? And on this side, so what I normally do is just to have the two sides, I separate them with a vertical line like that. All right, so the first thing that we're going to do, okay, this is in terms of x. How can we convert all of that in terms of x? Sine of 3x is sine of 2x plus x, right? This is divided by the sine of x. So what I'm going to do there, this looks like the compound angle formula. So this will be sine 2x cos x plus the sine, the cos of 2x the sine of x. Right, so let's say divide all of that by the sine of x. Right, let's try and squeeze all of that in. So we've got sine 2x, which gives us 2 sine x cos x multiplied. Remember, this entire thing that I've just written is just representing sine 2x multiplied by cos x. So do you see cos x times cos x will give us cos squared of x, right? Okay, so this is cos squared of x plus. Now, if I look at the right-hand side, already this tells me that my answer should be in terms of sine of x, right? So I'm going to convert this in terms of sine x. So I will say, well, cos of 2x is 1 minus 2 sine squared x times sine x divided by sine of x. Now, ladies and gents, I'm not going to touch the right-hand side. I'm just simply continuing with the left-hand side over to this side. What do I have? I've got, in my two terms, I've got sine x as a common factor. Let's take that out. So sine x, what do I have left? So that sine x I've taken out. I've got 2 cos squared of x, okay? And I've got plus 1 minus 2 sine squared of x. All right, ladies and gents. So this is divided by the sine of x. Right. Hope you can see where I'm going with this. Right, so all I'm going to do, I can see that my final answer has got only sine x, so I'm going to convert this in terms of our identities, right? So I am going to say, well, 2 cos squared of x is 2 times, that's 1 minus sine squared of x plus 1 minus 2 sine squared of x. Right, if I look at this, this would be 2 minus 2 sine squared of x plus 1 minus 2 sine squared of x. Ladies and gents, I'm sure you can see that 2 plus 1 gives us 3, minus 2 sine squared of x minus 2 sine squared of x gives us minus 4 sine squared of x. So therefore, left-hand side is definitely equal to right-hand side. I do apologize for that little bit of a mess there. It is quite a long, lengthy sum. In this case, it couldn't fit in the space that we had. Right, so I hope you got this. Right, so let's go on to the next one. All right, and they say to us, we need to, sine squared of x plus sine 2x minus 3 cos squared of x is equal to 0. They want us to determine the general solution of the above equation. Right, now, I want us to note there. Right, so we want to find the general solution of this. Right, now if I look at what we've got there, we firstly need to try and simplify as much as possible. Okay, so we've got sine squared over there, and we've got sine of 2x over there. Now, sine of 2x has got both sine and cos in it. Okay, so let's try and write it. So sine squared of x plus 2 sine x cos x minus 3 cos squared of x is equal to 0. I'm sure you can see that this is a quadratic equation, ladies and gents, right? So how do I solve this quadratic equation? I have to factorize. Okay, so I'll have, well, sine squared of x, that gives me sine x and sine x. And 3 cos squared of x, one of them has to be 3 cos x, and one of them has to be just cos x. Now notice our final answer, right, has to have a positive as the middle term. So which means the bigger product, 3 cos x sine x, has to be positive. The other one has to be negative. All right, and what do we eventually have? We've got sine x is equal to negative 3 cos x, and sine x is equal to cos x. Right, so we divide both sides by cos x. We do the same to the other equation. So remember that sine x over cos x gives me 10 of x, which is negative 3, or 10x, which is equal to 1. Now, ladies and gents, right, my my program is complaining now. Okay, actually my device is complaining. So x is equal to arctan of minus 3, or x is equal to the arctan of 1. All right, now remember we're looking for the solution between negative 90 and 180. So I'm going to take that from my calculator and say arctan of negative 3. I get a value of negative 71.57 plus k 180. Please remember, whenever you are solving, in this case, that's k is an element of integers. So we are looking for the arctan there. And for this one, x is equal to, arctan of 1 is 45, right? Plus k 180. We've already declared that k is an element of integers. Now, remember they did say that we need to look for, actually we're looking for the general formula, which means we're going to leave it here. But for 5.4.2, what we now need to do is find out the value of the angles between negative 90 and 180. So firstly, I'm going to say, well, if k is 0, right, then x is minus 71.57, as well as for this one, when k is 0, x is 45. And both those angles are actually between negative 90 and 180. Now, if I take k is 1, okay, for this one, if I make k equal to 1, that would be 180 minus 71.57. That gives us 108.43, and that is a valid answer as well. And if I make k equal to 1 there, that's 180 plus 45, which is 225. that no longer fits our restriction. If I make k negative 1, so we have minus 180 minus 71, which is outside of our restriction. And we've got, if it's negative 1 there, that's negative 180 plus 45, right? And that would give us, that's minus 135. And that also is outside of our restriction. So these are all the values of x, right? So we can put them in ascending order, that x is equal to minus 75. Actually, they're already in ascending order. 5, 7, that's 45, as well as 108.43. Right. And ladies and gents, that is how the cookie crumbles for this section. Really do make sure that you understand this section quite well. Otherwise, just go and look at the videos that I have of this very section. They will help you quite a lot. Right, ladies and gents, let's go on to the next part. Right, let's go on to question 6. They say the sketch the graphs of f of x, which is 3 sine x, and g of x, which is 10 of a half x. Right, so firstly, what's peculiar about the graph of f of x is that it has an amplitude change there. The amplitude is 3. And what's peculiar here is that they've changed the frequency to 1 over 2, right? Now, in this case, they said draw these graphs. I don't have a grid here. So what I'm going to do is I'm just going to try and draw the two graphs over here. All right, so that would be at 90. Okay, actually, let's just give it a bit more space because we said between negative 180 and 180. Right, so going to say, right, this is 90. And let's say that's 180 over there. Right, so please label your axes. So these are the y-axes and those are the x-axes. So we've got negative 90 and we've got negative 180. Now, what I'm going to do, just perhaps it would be helpful to also have your 45s there. Your steps should be 45. So negative 45 there. And that's minus 135, right? It's always helpful for the 10 graph. But now what we've got here is 10 of a half x. Now remember, our 10 graph usually would have an asymptote at 90, okay? Another one at 270, right? But because we're drawing, we can only draw, so this would be a full 10 graph. This is what it would look like, okay? But now, which means that our period is no longer going to be 180, right? So please remember, how do you calculate period? That will be, for the 10 graph, it's 180 divided by the frequency. Our frequency is the coefficient of x, so that's divided by half, and so that's 360. So, which means we're not going to have an asymptote as per usual at 90, right? But instead we're going to have an asymptote at 180. Okay, so I'm going to have, right, so meaning I'll have another asymptote over there. So usually the 10 of 45 is 1. So this time around, let's just say, okay, say that's 1, 2, and 3. So 10 of 45 is 1, but this time around it's going to be the 10 of 90. In fact, 10 of 90 is 1. Okay, and that doesn't change. Uh, 10 of 90 is negative 90 is negative 1. So I know that for that 10 graph, right, so there we've got it. And now, so this is the graph of g of x, right? I started with the graph of g. So for the graph of sine of x, so this would be the normal sine graph, but the only difference is that our amplitude would actually be 3 in this case. So remember that sine of 0 is 0, sine of 90 would normally be 1, but this time it's going to be 3, right? And 180 would be 0. So you've got a graph that looks like this. And of course, at negative 90 would have negative 3. Right, so this would be the graph of f of x. So the red graph is f, and the blue graph would be the graph of g. Right, okay. Right, now they say to us, write down the period of g. Okay, we've already done that. Okay, so the period of g would be 360. We said it's 180 divided by the frequency, and our frequency was a half. So the period would be 360. Right, now they say to us, write down the value of x for which the graph of g is undefined. So the graph of g is undefined, remember, at minus 180 as well as at 180. That's where we've got our asymptotes, right? So, so that's x is equal to plus or minus 180. All right, so that's where we have it. They say write down the range of h if h of x is f of x minus 2. Now I want you to think about it. The range of f of x is y is an element of minus 3 to 3. Right, now if I subtract 2 from that graph, so which means we are taking it down by 2 units. So I'd have y is an element of, notice this would be minus 3 minus 2, which would be negative 5, and 3 minus 2 would give me 1. Okay, so that would be the range of our graph. Okay, let me just remove this. Okay, this thing sometimes just becomes stubborn for nothing. Okay, so we said then we're going to have y is an element of minus 5 to 1. Okay, so that's the range. And they say how many solutions exist for f of x and g of x? I see 3 solutions. Where are they equal? 1, 2, as well as 3 over there. So we've got 3 solutions. Boy, am I glad they didn't ask us to find those solutions, right? Yeah, and that's how the cookie crumbles, ladies and gents. Please have a look at my videos on graphs, and they will really, really help you quite a lot. All right, let's move on to the next section. And now for question 7, they say in the diagram below, we've got PQ, which is a vertical pole, right, having a height of h meters. RQ and T are 3 points on the same horizontal plane, which is PR and PT are cables, and the angle of depression from P to T is 30 degrees. Right, so we are given all of that there. And they say PR is 3h and RPT is 2x. Now, ladies and gents, let's just find what we're given there so we can see on our diagram. Now, please, I want you to note this line here and the angle of depression, or our reference line for the angle of depression, this is a horizontal line. And so that means that if I look at this, then it is parallel to, the ground, okay? So in that case, it means that this angle here has to be 30 degrees as well, okay? Right, because of alternating angles, all right? And what else do we note? Now they say to us, write down the size of PTQ. So PTQ is exactly what we just found there. PTQ, so it's exactly that angle, and we said PTQ is actually equal to 30 degrees. Right, they say determine the length of PT in terms of H, right? So in which triangle do we have the most information, right? So I can see I'm looking for PT, right? So if I look at PT, it's this side over here, right? So in this case, I want PT in terms of H. I already have the opposite side there, which is H. So I can say in triangle, okay, let me just rather write on this side, in triangle PTQ, right? I know that the sine, okay, look at this, opposite over hypotenuse. So the sine of 30 degrees is equal to opposite, which is PQ, over the hypotenuse, which is PT. Now, I want to determine PT, so which means if I were to cross multiply there, so opposite over the hypotenuse, so I'm going to say PT, the sine of 30 is equal to PQ. So PT would be equal to PQ, which is H. In fact, I might as well, okay, let me write it over the sine of 30. Now, let's find out. In this case, PQ is H. Sine 30 is a half, so that's divided by 1 over 2. So to get rid of that half there, we multiply by 2 at the bottom, but what I do at the bottom, I do at the top. Okay, so I have got PT is equal to 2H, right? And please don't try to drag it, ladies and gents, and let's cut straight to the chase. Right, now they say to us, calculate the value of X, right? If RT is square root of 7H. Right, so they give us that RT value there. They say this is square root of 7H, right? Remember, we already have this guy as 2H. And we've got this angle here as 2X. So what this simply means is that we can actually say, well, in triangle PRT, so in triangle PRT, now notice I've got the two sides and the included angle, and I also have the side that is opposite that. So I'm going to use the cosine rule, right? I am going to say, right, RT squared, so RT squared is equal to PR squared plus PT squared minus 2 times PR times PT, the cosine of 2x. Right, now RT, that's square root 7H, and PR, I want you to note in this case, PR is 3H squared, and PT is 2H squared minus 2 times 3h times 2h, the cosine of 2x. So let's try and solve as much as we possibly can, right? Oh, by the way, sorry, this was supposed to be squared. So I'm left with 7h squared, right? Now notice I'll have 9h squared here plus 4h squared, right? So let's take that to the other side. Right, so square root of 7h in this case gives us 7h squared minus 13. So that will be minus 6h squared, which will give me, right, so you've got negative 2 times 3 times 2. So I have got 6 times 2. So this is minus 12h squared. So that was minus 12h squared. Apologies there. The cosine of 2x. All right. So in this case, what can I do? So cos of 2x. And so I'm going to divide both sides by negative 12h squared. That whole thing cancels that. Negative divided by negative, h squared over h squared. So that's 6 over 12, which is 1 over 2. So that means that cos of 2x is equal to 1 over 2. Now let's find the value of x. So 2x is equal to the arc cosine of 1 over 2. And remember that cos is equal to a half at 60 degrees. So that means that this is, we don't need to say plus 360k in this case. So 2x is equal to 60. And if we divide that by 2, then I get x is equal to 30 degrees. Right, ladies and gents, that's what we get over there. Yeah. All right, so we got that. So x is equal to 30. I hope that you've got that. And by the way, I would still advise, please go and watch my video on how to solve for 3D trigonometry. Right, it would really make this section much easier for you. All right, let's go to the next section. And now for our favorite section, Euclidean geometry. Right, in question 8, they say in the diagram below, we've got the circle having a center O. And by the way, ladies and gents, if you remember, for those of you that have watched my videos on this section, right, please, right, the moment they say center, I'm going to mark my radii, right? So that means OT is equals to OU, okay? Those are my two radii. So that makes triangle OTU an isosceles triangle. Right, now they say to us, UT, S, and V, right? It passes through UT, S, and V. So that means that is a cyclic quad, right? So you've got a cyclic quad there, UT, S, V. And they say PUK is a tangent. So we're going to look for the 10 chord theorem and 10 radius theorem, okay? And yeah, those are the two that we can apply. We don't have two two tangents there. So they say TS is parallel to PK. So that means that we may have some alternating angles, corresponding angles, as well as co-interior angles, right? So UOG is a straight line, okay? They say TSU is 75 degrees. Right, now let's find out what they are looking for. So they say, calculate with reason the size of O1. So if you notice there, O1 would be equal to 2 times angle S, TSU, right? So that's angle at center equals to 2 times angle at circumference. So that means that angle O1 is equal to 2 times angle TSU, which is 2 times 75, and that's 150. Okay, and why is that? Angle at center equals to 2 times angle at circumference. Okay, you'll finish that off, right? And then they say we should look for U5. Now, if I look at that, that's definitely 10 chord theorem, right? So there's our chord, right? The angle between the tangent and the chord will be equal to the angle on the opposite side of that chord. So it would be equal to 75. So in this case, U5 is 75 degrees. And the reason for that is the 10 chord. In fact, let me say U5 is equal to TSU, which is 75 degrees, and that's 10 chord. Okay, right, and then we look for angle T1. Right, now ladies and gents, we already found that this angle here is 150, right? And you'll notice that T1 and U4 are equal because of those equal radii, right? So if angle O1 is 150, right? If we take the sum of angles on a triangle in triangle OTU or TOU, right? That would be 180 minus 150, which would give us 30 degrees. And if we divide that by those two angles, that gives us 15. So I'm going to say T1 is equal to 15 degrees, right? But just for me to show you how we got that, we said in triangle OTU, we said because OT is equal to OU, those are radii, right? And so what that means is that in this case, angle T1 is equal to U4, right? These are angles opposite equal sides. All right, so that's an isosceles triangle. And so that means that T1 will be equal to 180 minus the angle O1 rather, which is 150, right? But because those two are equal, then we divide that by 2. So we get 30 divided by 2, which is 15 degrees. Right, so we can say angles opposite equal sides, or we could have actually gotten it another way. Again, ladies and gents, I hope that you could see it. So I could have used angle U4 and U5, right? And what I note there is that line from center perpendicular to the tangent, so that's the 10 perpendicular to the radius theorem, right? So that means U4 and 5 make 90 degrees, but we already found out that U5 is actually 75, so U4 is actually 15, right? That's 90 minus 75, and so that means that T1 will be equal to, that will be 15, right? I hope that you got that, ladies and gents. Right, let's find angle V. So if I look at angle V, right, so where or how can we get that angle? Now that we've got the angle V1, or in this case, I think a way in which we can go about that, we can look at the cyclic quad, right? So we know that this guy is 15 degrees. We know this is the line from center. Okay, so, oh, by the way, in fact, we didn't even need to go all the way there. Remember, we've got our parallel lines. So as long as we've got parallel lines, then it means that we've got alternating angles. So if this is 75 degrees, then it means that entire angle there would be 75 degrees, right? But in this case, what are we looking for, right? We are looking for angle V. So if this entire angle is 75, okay, that means that this angle V would be 180 minus 75, which is opposite angles of a cyclic quad, right? So 180 minus 75 would actually give us 105. So angle V is 180 minus 75, which is 105. That's opposite angles of a cyclic quad. Right. Ladies and gents, you would write this out in full, right? I'm just showing you. So the steps that you would have followed there is that you'll say angle U5 would be equal to angle UTS. Okay, so which means it's that entire angle there, right? And you say that those are alternating angles, right? And so in that case, angle V, so angle V plus UTS is equal to 180 degrees. That's opposite angles of a cyclic quad. Okay, and so angle V is equal to, as I said, that 105. 180 minus 75, that gives us 105. Now let's look at U3. Right, so in looking at U3, so we are looking for this angle over here, right? Now, ladies and gents, there are quite a number of ways in which we can look at that. Okay, so we can firstly look at the cyclic quad. All right, but what I also do notice there, right? So we've got an entire angle that is actually 90 degrees there, right? So if you notice, this angle over here, these are co-interior angles, right? So if this guy is 90 degrees, that means that angle would also be 90 degrees, okay? So that means G2, so G2 plus angle, I'll call it GUK, equal to 180 degrees. Okay, so those are co-interior angles, right? But we already know that GUK is 90 degrees by virtue that, in fact, let's just say it there. So GUK is equal to 90 degrees. And this is because tan perpendicular to radius. Okay, so then it means that GUK is 90 degrees, right? GUK is also going to be equal to 90 degrees. Now, if you notice there, ladies and gents, okay, so I already know that this is 90 degrees. This is 75. So what does that make this angle here? That would be 15 degrees. Okay. So that means that U3 is also equal to 15 degrees. I'm sure you guys could find other ways of expressing that angle, right? Please do say it in the comments if you've got another way. So that's equal to 15. So remember we've said GUK is 90. So in triangle GSU, right, we've got 90, 75, and so that means U3 is 15 degrees. So equals to 15 degrees, or rather let me say 180 minus 75 plus 90, which is 15 degrees. Angles in a triangle GSU. Right. And then we're looking for G2. All right. Actually, we've just expressed that there. G2, actually we said it was G2 there, we said it's 90 degrees, right? So G2 is equal to, in fact, let's rather say G2 is equal to angle GUK, that's what we said. Or we can even use alternating angles, that this angle is equal to that angle over there, and that would be 90 degrees. Okay, we can say alternating angles, right? And in that case, remember that we know that those two lines are parallel, which is TS as well as PK. Right, ladies and gents, that is how the cookie crumbles. So let's go to the next section or next part. If it is further given that TS is square root of 80, so let's look for that TS. Where is TS? Okay, so TS is this entire side. So square root 80, this entire line here, right? They say calculate the length of TG with reasons and leave your answer in simplest said form. All right, so let's look for TG. Where is our TG value? Okay, so now we've just found out that this is perpendicular. So remember, line from center is perpendicular to a chord, then it means that it will bisect that chord. So TG will be equal to TS over 2, okay? Right, and in this case, that means it's root 80 divided by 2. Okay, they said we must leave our answer in the simplest said form. So square root of 80. Okay, please note, ladies and gents, take that outside the square root. So that would give us 2 root of 5. Okay, right. Now I want you to please note why is that? Okay, we said in this case we know line from center is perpendicular to the chord TS, so therefore it means it bisects that chord, and as a result it means that TG is equal to GS. And so if the entire line TS is root 80, then it means that TG must be a half of that. All right, so that is how the cookie crumbles. Ladies and gents, we are almost done. Let's go to the next section. And so we look at question 9, all right? So they want us to prove there. They say in triangle ABC below, M is a point on AB and N is a point on AC such that MN is parallel to BC. Right, so they want us to prove the theorem which states that AM over MB is AN over NC. Now, ladies and gents, the first thing that you're going to do whenever you are proving this theorem is that you're going to draw perpendicular lines, right? So I'm going to have a perpendicular line there. Okay, let's call this line H. Okay, so let's call this line H. All right, now, if I take the area of the smaller triangle, right? So in this case, I am also going to have that other triangle there, right? So if I take the area of the smaller triangle, so I'm going to say the area of triangle AMN, right, over the area of triangle. Now I want you to see there, so that's MBC, right? MBC. Now, remember the area of a triangle is half of the base. Now, in that triangle, AMN, the base would be this entire side, AM, right? So that's half of AM multiplied by the perpendicular height, and that perpendicular height, I've called it H, right? Divided by, okay, MBC, right? This triangle over here, I want you guys to note in this case, that's half of the base again. What would be my base? My base would be MB, right? Multiplied by, now that is not a perpendicular height. In that case, the perpendicular height to that triangle, right? If I look at it, that would also still be H, right? So if I look at that triangle, in fact, maybe if I do this, okay, right. So I see that the perpendicular height to that triangle would still be, in that case, H. So this would be, that's half MBC. Right, so I've got H and H cancelling out. Right, so I know that this will give me AM over MB. Right, now, in this case, let's find the next one. So they say to us, so we need to also find the ratio of AN over NC, right? So what we're going to do is have another line. Okay, so if we've got another line there that is perpendicular, so I'm going to take the area of AMN again, right? Let's say that height there, let's call it another, let's give it the name L, right? So we'll say that is L. So triangle, right, so NBC, right? So again, for that triangle, your height would also be L. So that means if I take the area of triangle AMN divided by the area of triangle, so we've got NBC, and this would be half. Again, now our base would be AN, this side here, times perpendicular height is L. This is divided by the half of, right, NBC. Once again, that's NC. That's our base, multiplied by the perpendicular height there. This would be our line L, right? So again, you've got the same ratio over there. So that cancels with that. So we are left with AN over NC. But if we look at those two, right? If I look at the area of, AMN is the same thing. But if I look at those two, because AM and NC are the same size, as well as, they've got the same height as well. So which means the area of triangle, so the area of triangle MBC is the same as the area of triangle NBC, right? So therefore, in this case, that means that AM over MB must be equal to AN over NC. And we have proven exactly that. And that's how the cookie crumbles, ladies and gents. Please look at all the proofs. They are in our grade 11 videos, and they will help you a lot with this section. Okay, right, let's go on to the next question. Right, so let's quickly have a look at question, the continuation of question 9.2. So they say in the diagram below, we've got PQR, which is drawn, which is such that EG is parallel to QF. Okay, we've got that there. And they say EF is a straight line. Okay, and QE to ER is 2 to 5. Now, what I normally like doing is, as soon as they give me that information, what I'm going to do, so QE to QR, so this means this is 2x over ER rather, and this would mean this is 5x. All right, please put a variable to that ratio. And then they say to us PR is 49 units and FG is 10 units. Now, firstly, they want us to calculate the length of GR. So we need to calculate that length there. Right, so what I'm going to do, ladies and gents, is that I am going to use, right, if firstly, you see there, we've got a ratio between QE and ER, right? And this would mean it would be the same as the ratio between FG over GR, right? Okay, so this is line parallel to the third side of a triangle. So let's do that first. So we're saying, so in triangle QFR, right? So we said QE over ER is equal to FG over GR. Okay, and this is, remember we said that gives us 2x over 5x, right? Okay, because we're given the QE over ER, right? So FG is 10, okay, over GR. This is 2x over 5x. Okay, we can remove the x's there. And if we cross multiply, so 2 times GR, that's 2GR, which is equal to 10 times 5, which is 50. If we divide both sides by 2, then we see that GR is 25 units. All right. So this means the length of GR is 25 units. All right, now they say prove that FE is parallel to PQ. Okay, they're saying prove FE parallel to PQ. Now, ladies and gents, we already know what the ratio of QE to ER is. So if I can prove that the ratio of PF, right, I want you to see this. If those lines are parallel, then it means the ratio of PF to FR must be the same as QE to ER. So what would be the length of PF? Right, let's find the length of PF first. So the length of PF, remember the entire length is 49. So PF is PR minus minus GR and minus the FG. Okay, so that entire side minus this minus that gives us PF. So this gives us 49 minus 25 minus 10. So I've got 24 minus 10, so that gives us 14, right? So PF is equal to 14 units. All right, now let's check. If I took the ratio of PF, as I said, PF over FR. Now we know that FR would simply be FG plus the FG times FG plus GR, right? So that means it's 10 plus 25. So that's 35. Okay, right, so that's 35 units. So let's find out what is the ratio of PF divided by FR. Okay, so this would be 14 units PF divided by FR, which is 35 units, right? And look at this. If I take this, 7 goes into 14 twice and into 35 5 times. So I get a ratio of 2/5. Now note, ladies and gents, we're applying the converse of the theorem. So we're saying, but PF over FR is equal to QE over QE over ER, and both of them are actually equal to 2/5. So therefore, it must mean that the two lines are parallel. FE is parallel to PQ, and I'm going to say because converse of line parallel to the third side of a triangle. Okay, right, so that means those two are actually parallel. Right, ladies and gents, that is how the cookie crumbles. We're left with the final question. All right, and let's go right for it. So they say to us in the diagram below, we've got A, B, C, and D, which are points on the circumference of the circle, PQ and QC. They are drawn, and P and Q respectively, and intersect at C. All right, so they are telling us what we've got there. Now they say QP is joined to DB, So DB is parallel to PQ. So there's our PQ over there. Okay, and there is DB over there, right? So we're going to find our alternating angles when lines are parallel, or even our corresponding angles. Right, so they say to us QB is 5 times BC. All right, now let's get right into it. So essentially, what we've got there is that if BC was going to be X, right, then it means that QB would be 5x. All right, I like expressing that in terms of those ratios, right? Or you can rewrite that as QB over BC, right? You'll see that this gives you 5/1, right? So that means that this is 5 times this guy, okay? Right, now they say prove that CT over PC is equal to 1/6. Now CT over that entire side PC. Now I want you guys to please note in this case, I have got, now please note, I'm looking for CT over PC. So that should be equal to, because we've got lines that are parallel over there, so that will be equal to BC over CQ, right? So let's find that out. So in this case, I've got CT, let's say in triangle. Okay, let me just, so that I have space. In triangle, CPQ, I know that CT over PC, right, is equal to BC over, now note this is BC over QC, right? But we said BC is X and QC is actually QB plus BC. So this is QB plus BC. And that means in this case, this would be X divided by X plus 5X, right? And so this gives us X over 6X. And so, ladies and gents, you can see how CT over PC will give us 1/6. Okay, right, so we've gotten that from that. Okay, I know I didn't write it quite nicely there. So let's say CT over PC is equal to X divided by, remember we said QB is 5X, and we said BC is X, and so that gives us X over 6X. So if you cancel those out there, that gives us 1/6. Right, now they say prove that QAC. All right, so let's try and indicate those triangles. So QAC. So QAC, which means we're dealing with that triangle over there, right, is similar to triangle QBD. So we're looking for this triangle over here. So I like to mark my triangles so that we know which triangles we are trying to prove similar. Right, firstly, you can see that angle Q is common. So Q is common. And by the way, guys, you only need to prove two angles equal. And the third one automatically becomes equal because, it's the third angle of a triangle, right? So Q is common, right? And what do we notice? Angle C is equal to angle D. And why are they equal? Right, our butterfly theorem. So in that case, you can see that we've got what we call angles and on the same segment, right? So we've got angles, same segment. Okay, so those are equal. Now we've got two sides or two angles that are equal. So as a result, right, automatically it means that angle B2 So therefore, B2 would therefore be equal to, right, in this case, A1. Of course, there could be another way in which you could prove those equal. And you can say this is the third angle of a triangle. Third angles on a triangle. So therefore, that means that triangle QAC is similar to triangle QBD. Triangle QBD. And the reason for that is that we found angle, 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 right? Very important for us to be able to prove that, right? Now, finally, we've just proven those angles similar, those triangles similar. So they want us to prove this entire thing here. So what I ask us to do is always go for, your proportionality theorem. So I know that I'll say QA. So QA over QB will be equal to QC over QD, which is equal to AC. Okay, so AC over BD. Right, so now let's see, what are they wanting us to prove? So you've got QD as well as QA there. Okay, so which means I'll take this ratio together with this ratio here. So let's cross multiply them. QA times QD, right? So QD times QA is equal to QB multiplied by QC. Right, now we need to express both of them in terms of BC because I see that we've got BC squared there. Now if I look, let's see, QB, how is QB related to BC? Right, so QB is 5 times BC, right? We've already proven that, okay? So QB over BC, that's 5 over 1. So meaning, just like was said there, QB is 5 times BC. And what about QC? So QC is this entire side here. And we've just proven that QC is actually 5x plus the x, right? Which gives us 6x. So this gives us 6 times BC. And so, ladies and gents, we've actually just proven it. QD times QA. 5 times 6 is 30. That's BC squared. All right, and that is how the cookie crumbles. And that's how we come to the end of this exam. Very interesting questions. Please just have a look at it once again. And please don't forget, we've got our camp that is coming up, ladies and gents, which is from the 23rd to the 27th of September. All right, where we will be discussing all things maths and science, just so that we get you ready for that final exam. Right, all the details that you need will be on the description. You can use the cell phone number, okay, the WhatsApp number that is on the details of this video, right, the description of the video. Otherwise, ladies and gents, I'll see you guys next time. Sharp, sharp.